Welcome to the Mechatronics Revolution Fundamentals and Core Concepts. In this lesson, we'll discuss the role of mechatronics in the field of robotics. The learning objectives of this lesson are to first explain the relationship between mechatronics and robotics. Then we'll describe the role that mechatronics plays in the overall creation of robotic systems. Finally, we'll illustrate the application of mechatronics in several interesting robotic systems. So as you can see here, we have three different robots. Now each of these robots is quite different, and they serve quite different purposes. But they all share mechatronics components. For here we have a microcontroller, for instance, sensors, servos, and other electronic components. So even though these three robots are quite different, they all rely heavily on mechatronic components to operate. So when we think about mechatronics and robotics, we might ask, what's the difference between these two fields? Well, robotics is a large, highly interdisciplinary field covering a lot of different areas. For instance, path planning, computer vision, mechanical design of manipulators, robotic legs, or robotic arms. Controls and dynamics also play a big role in robotics, as does human-robot interface. And you can see that we've also included mechatronics as a component of the overall field of robotics. Robotics really encompasses all of these different areas to create robotic devices. Mechatronics could be viewed as a component of robotics, an integral part of the overall field of robotics that deals with hardware-software integration. The implementation of robotic systems can't really be accomplished without some mechatronics components. And we can see that with the three different robotic systems that we've shown here. Let's look at a few interesting robotic systems and discuss the mechatronics components within these systems. First, we have this Krang robot that's used here at Georgia Tech. Now this Krang robot has several different components and actuators. You can see that there's encoders, for instance, in the wheels. You can see that there's motor driver circuits that drive the servo motors in the arms as well as the wheels. There's sensors on the ends of these arms that might measure different things and serve to feed back information to the closed-loop control system. We also have onboard sensing on the base to determine how this robot's oriented. And finally, we have stabilization and control software that's implemented on embedded computers and microcontrollers within the Krang robot. Looking at another type of robotic system, this drone, again, we can see numerous different mechatronics components highlighted in blue. The motors, the onboard flight computer, the inertial sensors, and the electronic speed controllers or motor drivers are all critical mechatronics components that integrate with the other aspects, for instance, the computer vision algorithms, the wireless receiver and transmitter, and the stabilization algorithm to create a very highly functional robotic device. A third example is this agricultural robot. So this robot is essentially a robotic manipulator with a specialized end effector. There's embedded computers, servo motors, servo motor drivers, and sensors that are all mechatronics components that are tightly integrated on this robot with the other robotic system aspects like image processing algorithms or motion planning algorithms. It's important to understand that, for instance, an image processing algorithm would not be considered a mechatronics component, but would rather be considered more of a robotics component. The mechatronics components really deal with the hardware-software integration in terms of actuation and sensing and embedded computing. While robots rely on mechatronic devices in some form to operate, it's important to also understand that not all mechatronic devices are robots. So even though robotic systems require mechatronics, not all mechatronic devices would be considered a robot. For instance, a hard disk drive, a printer, or a Segway are not really robotic systems, but they are mechatronic devices. Many mechatronic devices that you may see or use every day don't have intelligence, they don't have initiative, they don't have decision making, or say adaptability that we would see in robotic devices. So many mechatronic devices that are built would not really be considered robots, but robots could not be built without mechatronics. To summarize what we've learned in this lesson, robotics is a broad field that encompasses a lot of different theoretical and applied topics, but it includes a component of mechatronics and control system implementation. And so we should view mechatronics as a critical piece of robotics. That being said, even though all robotic systems involve some mechatronics components, we can also use the field of mechatronics to build devices that aren't considered robots.